Hello everybody! Welcome back to my YT channel. This is again, I am a singer, eternal voice, your YouTube content creator, and at the same time, your social media influencer, small YouTuber! Oh my gosh! Okay, so I had already charged my microphone. I cannot use that for a moment, but let's discuss to you guys without microphone, right? Okay, we have, I think this is problem number 5 in continuation to the previous problems that we solved yesterday, right? It's related again to, stoichiometry calculations in chemistry. Okay? Okay, shout out Jen Caron. Okay, actually, my nephew told me that their topics today are, related to deoxyribonucleic acid and genes. But that topic really is, I'm not really that good for that. Though I have, uh, knowledge, but not really that, adequate. Because that is more on biology or biochemistry, right? Okay, but of course, that is not our topic today. I cannot relate, okay? DNA and genes daw. Hi, GK! Oh my gosh, shout out to you. Oh, shout out to you, JK. Shout out to you also, Ma'am Greta Bacalso. Okay, teacher Greta Bacalso. Oh my gosh. Okay. And teacher Dadesh. Wow, Dadesh Bacalso. And also to Zyka Gray and Nina Ziffer and Van der Waals Flores. Oh my gosh. Okay, going back. Okay, the problem goes like this. 4.85 liters of ammonia gas at 27 degrees Celsius at 1.45 atmosphere was mixed with 5.23 liters of oxygen gas. Hindi ko makita guys, no? Okay, ganon. Diba? At 32 degrees Celsius at 1.6 atmosphere to produce nitrogen gas. Determine the volume of nitrogen gas produced if it was isolated and collected at 37 degrees Celsius at 1.52 atmosphere. Wow! Diba? Okay. Solution. Given. Ganon. Given or beta. First, 4.5 liters of ammonia. So let's have this. We need to identify what are being involved. Ammonia, nitrogen gas, ganon. And also oxygen gas. So a lot of gases, right? Oh my gosh. In the atmosphere, nitrogen gas, oxygen gas, ammonia, blah, blah, blah. Okay. First, we need to consider the ammonia. Ammonia data. Ganon. Ganon. You see that or no? Nakakaloka. So, ammonia data of volume, ganon. 4.85 liters. And then temperature, okay. 27 degrees Celsius. So, we need to convert that automatically with Kelvin to make it easy, right? Okay. 27 plus 273 is equal to 300 Kelvin, mga palangga. So, 300 Kelvin, right? So, the temperature, the pressure, okay. The pressure is 1.35 atm. Automated teller machine. No, it's not. It's atmosphere. Okay? Like that. And then oxygen gas. Oh my God, nakakaloka. Oxygen gas. We have V2 of 5.23 liters, mga palangga. Temperature 2 is 32 degrees Celsius. Convert that to Kelvin is gonna be, oh my gosh, I cannot calculate that in my brain cells. I have to do it by calculator. Okay, 32 plus 273 is equal to 305, mga palangga! Okay, 305 Kelvin. And now the pressure also of oxygen is equal to 1.6 atmosphere. Wow. Okay, and the last but not the least, the data of nitrogen gas. Okay, N2, right? So, N2, ganon. So, N2, volume 3, let's say volume 3, we have, okay, this is the quantity being asked. So, we have to put question mark. Ta-da-da-tang. Oh, diba? Nakita niyo guys? Question mark ang volume sa nitrogen gas, which is being asked problem. Now, it was isolated and collected. It was being isolated. It's very clear, huh? It's separated because it's mixed. The ammonia and oxygen gas are mixed, but the N2 is being collected after the products produced. And one of the products produced are nitrogen gas for this. Okay, like that. And then it was isolated and collected at 37 degrees Celsius at 1.52 atmosphere. Oh my gosh. T3 is equals to 37 degrees Celsius plus 273 again. Okay, ganun. So it is calculator. Okay, 37. 37 plus 273 mga palangga. 310 degree, 310 Kelvin lang siya. Okay? Get the point. And then the pressure will be 1.52 atmosphere. Okay. 1.52 atmosphere. Now it is obviously gases, right? Gases. So this is gas stoichiometry calculation. It doesn't involve solid substances, right? And it doesn't also involve liquid substances, I think so. But let's check first the chemical reactions. If you see problems like this, there are a lot of elements being added, whatever, like that. You need to determine the chemical reactions first, okay? Unless it is only one element, then you don't have to do the chemical reaction. But in this case, a lot: ammonia, oxygen, nitrogen, fibroblasts, and so okay, like that. So in this case, there are a lot of data. You get the point? There's a lot of data. So obviously, we can use the standard formulas, equations of calculations. Okay, not the dimensional conversion way of solving. But if you want also, you can, but it's not really with significance. Oh my gosh, what's happening? Oh, like that, okay? So that's it. Now, so what comes in our mind? Volume 1, temperature 1, pressure 1, like that, blah, 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 so on. So you can say, it's a combined gas ideal, formula. So you will say, P1, V1, T1, N1 is equal to P2, V2, T2, and N2, right? Combined gas equation. Combined, meaning it was being combined the laws of Boyle's law, Charles' law, Gay-Lussac's law, Avogadro law, and Dalton's law, pressure, and everything, okay, regarding gases, okay? So this is going to be the equation we use. First, option 1. Okay. Option 2, we're going to use the commonly used and popular equation. PV is equals to nRT. Okay. This is very common, right? Option number 2. Okay, like that. Now it's going to be looking also for the chemical equations later, for a little bit of, conversion, but not really that the long conversion, what I mean, okay? So, you get the point. Okay, sometimes you only take a look for the final chemical reactions, but no need to, you need to convert or whatever, okay? Just use these formulas if you want. Okay, let's analyze first, huh? So, what is being mixed? Ammonia and oxygen, right? Okay. Ammonia and oxygen, so a lot of given, right? We can substitute that here. Substitute that there because we have a lot. Okay, and what is missing? N1 and N2, meaning the number of moles of ammonia and the number of moles of oxygen. Something like that, right? So we can have that also as our option. Okay, or you can do individually. Okay, you can do individually, right? By getting the number of moles of N ammonia and also the N of oxygen gas. N meaning gas is number of moles. As I always teach you a long time ago, small letter N in chemistry is always number of moles. Okay, otherwise specified. Okay, you get the point. So like that. So we need to compute the number of moles of ammonia, and we need to compute also the number of moles of oxygen gas. Either we can use this combined gas law equation, or we can use the PBRT individually by ammonia and oxygen gas, and we can get the number of moles each like that. And later on, we can use that to N2 here. Okay, like that. You get the point? But this problem guys is unique and special because as you can see here, we have reactants, both have data. Reactants for ammonia and also oxygen gas. So both have data. We are loaded with too much data. Okay, the techniques and chemistry calculations regarding this topic, especially gas, right? So I think it's also applicable in liquid. But sure, it's not applicable in solid, but something like that. But just have this concept. If the reactants having a lot of data, okay, normally the reactants are only two, okay, two. Element plus compound, compound plus compound, element plus element. It's also unusual to have three as your reactants. Always remember that also. As you can notice in the chemical reactions always, it's limited to two. Have also sometimes, but it's not really practical to have three combinations. Usually two you'd shot. Okay, but the products, it's expected more than two. So notice it. Be observant. Especially if you're studying chemistry right now, be observant. Most of the reactants are always two, and then the products are also two or more. Okay? Like that. Get the point? Okay. In this case, ammonia gas plus oxygen gas. And we need to make our chemical reaction because in the problem, it is not mentioned. Okay? So we will be the one to make. Okay, ganon. Sorry guys, medyo akong bored. I'm not contented with my whiteboard. It's not enough in my discussion. Oh my gosh. Okay, so how can I do this? I will erase the data, huh? In a way, we can trace back here because it's being reflected here. Okay, I will erase this for the purpose only of discussion. That the first step is we need to present the data and the given, but I have to erase because there's no more space in my whiteboard. I cannot explain further if this is the case, right? Ganon. Then go back to the problem. Okay, now, okay. So we have mga palangga. Okay, we have the chemical reaction of ammonia. Okay, like this. In this gas stoichiometry calculations also, you need to master the prediction of the products. You have to master also the prediction of the products, and it's expected also that you have a very rigid knowledge on the different types of chemical reactions like that, and also you have a thorough knowledge of molecular compound and ionic compound and those bandings, chemical banding, the covalent banding, the hydrogen to hydrogen banding, something like that, and the ionic banding. And then you also have an adequate knowledge of the Lewis dot structures, sharing and transfer of electrons, something like that also. And you have also knowledge regarding the the Bronsted-Lowry principles, like that, and also the proton donor, proton acceptor, so there's a lot to be considered also. And also the Arrhenius theory of giving or releasing ions into a solution. Could it be an ions or a cation? So you have also huge, or let us say, knowledge accumulated in your brain cells, further seeing or facing these types of chemical gas stoichiometry problems. Okay, so we need to prepare first before going to this kind of problems because a lot will be used here, something like that. Okay, now ammonia plus oxygen gas. So it's very clear that the N2 gas is already mentioned. Now the partner is not yet mentioned. What is the partner for the products? Okay, something like that. Now going back, see, ammonia can act as an acid also, can act as a base also. Sometimes it will donate a proton, sometimes it will accept a proton, something like that. Okay, but most of the times this ammonia behaves as an acid. Okay, because Usually, most of the times, this ammonia is a proton donor, something like, because there's a presence of the hydrogen, the proton, okay, something like that. And the partner also is oxygen. So oxygen is electronegative with a charge of -2, something like that. So in this case, we treat ammonia that will donate the proton. So I will put an arrow, tararat, ganon, going to the oxygen. Okay, the H proton will be donated to the oxygen gas. Okay, in this case, ganon. So if this be donated, what will happen? Okay, the oxygen will accept the protons, of course. Okay, it will have additional H. You get the point? So additional H, so it will become H. Okay, and this O2 already, so H2O, ganon. Okay, you get the point? Okay, H2O. Why? Of this hydrogen donated proton to oxygen. Okay, so Sotero, why you did not put 3? It's not practical to put all the 3 of the hydrogen in the subscript because, guys, there's no compound such as NH only. Okay, NH, the lowest combination of a compound regarding to the partnership of nitrogen and hydrogen is only amine or amino, the base, the nitrogenous base compounds of all amino acids that we take in our body. Both the essential amino acids and non-essential amino acids inside our body, the building blocks of protein, so that it gives us energy like that. So amine is NH2, okay, not NH. Then that's the reason you cannot give all 3 of this hydrogen going to the oxygen if you want really H3O in the product, right? Because we have also the concept that H3O is a hydronium ion. Okay, it's also released in the solution as Arrhenius theory described. But Arrhenius will not be applicable here. It's only Bronsted-Lowry principle. Okay, like that. You need to, what's the principles all about? So that you can apply that in the chemical reaction. You need to really understand what's happening. Something like that, okay? It's not really that guessing or memorizing what will happen, something like that. You need to know the mechanism of a chemical reaction, something like that. Okay, so it will become now H2O, and then it will lost going to the oxygen. What will remain is the nitrogen gas. Okay, like that. So if you try to be strict in this particular reaction, this is only single replacement reaction. Single replacement reaction. It's not double displacement reaction because one element ammonia plus compound ammonia plus one element man siya. Double displacement is R compound plus compound, but this one is compound plus an element, so single replacement, something like that. Okay, so it was being replaced here, the nitrogen was being replaced, okay, with hydrogen. That's why H2O, ganon. And N2 will split, something like that, and N2 will go to the atmosphere. Instead of going to the atmosphere, guys, it will be collected and isolated here. It was isolated and collected at 37 degrees Celsius. Oh, ganon. So meaning to say there's an apparatus or whatever to collect and isolate the nitrogen gas produced in the reactions, oh my gosh, in the chemical reactions of ammonia and oxygen gas. Diba? It's very clear, mga kapatid. Uy, mga palangka, are you listening? Shout out to Gabriel Lapos, to the students. Oh my gosh. Ganon. Now, we have another chemical reaction. Ammonia plus oxygen gas is equal to nitrogen gas plus water. And the water here is liquid. Then barren, it will vaporize later on. Vaporize. So vaporization takes place after because water is highly volatile, something like that. If you will just put that outside and there's a presence of the sunlight, then it will vaporize completely later on. Okay? That's the one property, physical property of a water is the volatility. The ability of the water to be vaporized into the atmosphere. That is volatility. Okay? So like that. Okay, now going back, we need to balance. So we can balance this by visual inspection only, trial and error method. We don't go to the algebraic expression way of balancing the chemical equation because you know it will take time and then it's very easy to balance this one also. We have only a maximum of 3 atoms of the hydrogen, so it's not an issue, right? In equation software, it's not an issue to use the trial and error method of the balancing the chemical equation. Unless it will involve a lot of, you know, atoms, moles, subscripts, whatever, and then we need to use the algebraic expression of balancing the equation. Okay, guys? I'm talking too fast, right? Okay, so it's gonna be like that. Now, we have to balance the equation. Nitrogen gas 2, 2, hydrogen 6, we have to put 3 here, and then we have 3, oh my gosh, 3 oxygen. It's gonna be oxygen here is only 2. What we will do in this case of situation? I cannot put 3 because it will become 6. This is trial and error method, huh? And then 3 in the right. So I cannot do that. And I cannot also put 2 because it will become 4 and 3 and it's not balanced. It's not really, you know, it's not compensating the equality. You know, they are not equal. If I will put 2, 3, blah, blah, blah. In this case, if you encounter like this in a trial and error method of balancing the equation, we need to use fractional form. Okay, fractional form. So the first fractional form that you'll be able to introduce starting in the minimum level, something like that. You will not go to the up, you will start to the minimum. So what is the minimum? For example, 1/2. Okay, 1/2, 2/2. 2/2 is only one we need to include. 2/2, 3/2, ganon, okay? 5/2, 7/2, ganon. I don't include the even because it will become, you know, divisible by 2. And it's not already a fraction. Actually, I'll put 2/2. For 2/2 is equals to 1, ganon. 4/2, 4 divided by 2, ganon. 6 divided by 2 equals 6. I don't have to include that one. So I have to go with the add fractional form. Improper fraction, meaning to say the numerator is higher compared to the denominator. So it's gonna be 1/2, 3/2, 5/2, 7/2, like that. And I have to choose from the minimum level first before going further, and that is the procedure of balancing the chemical equation. In this case, that it cannot be balanced with the whole figure starting from 2, 3, 4. It's not possible, so I will go to the fractional form. Ganon. So if I will start 1/2, guys, if I will start 1/2, okay, 1/2 times 2 will be becoming 1. So oxygen 1 here, there's a 3 here. I will never use 1/2. Oh, I will never use also 5/2 and 7/2 because it's already maximum. As I said earlier, I will go minimum. So 3/2 is the last. So 3/2, ganon. Okay, 3/2. What you notice here? If you multiply both sides by 2, okay, 2 times 3/2 is equals to 3, in which 3 moles of oxygen will equal to the 3 moles of oxygen in the product. So I have to multiply this both sides with 2, so the denominator of the 3/2 will be cancelled, something like that. So okay, 2 times 2 is equals to 4 ammonia, meaning both sides will be multiplied by 2, no escape. Like that, okay? So 3/2 times 2 is equals to 3O2. Then 2 and 2 plus 6H2O. And this is our final equation. And let's check if this is balanced completely. So 4 nitrogen, 4 nitrogen. Oh my gosh. Hydrogen 12, oxygen 6, and oxygen 6. Perfectly balanced. Okay, something like that. I need to erase this first chemical reaction. And we need to transfer this balanced chemical equation at the top so that we can easily solve this one. Okay, something like that. Okay, so 4. I have to adjust, guys, because my whiteboard is very small. I cannot too much write. Something like that. So there's a restriction. Oh my gosh. Okay, limited space. Ganon. 4 ammonia plus 3 moles of oxygen gas is equals to 2 moles of nitrogen gas plus 6 moles of water. Oh, ganon. This is our balanced or perfect chemical equation. Okay, mga palangga. Oh, now, this final chemical reaction have 4 moles of ammonia, 3 moles of oxygen gas, 2 moles of nitrogen gas plus 6 moles of water. This is called stoichiometry relationship, meaning to say the amounts are exactly specified in the chemical reaction, specific amounts, meaning the number of moles. Through that number of moles, we can calculate the mass by relating to its individual molar mass or molecular weight, something like that. Now solve now. Okay. Guys, in this case, we need to have another theory or concepts and principles that if in this case, guys, the reactants are having so many data, we need to apply the law of limiting reactant and excess reactant. Okay, limiting reactant and excess reactant. Meaning, we have to utilize the limiting reactant because it is the one will be in control. Excess is naturally is abundant, so we need to go there. We have to adjust for the limiting reactant. Always the limiting reactant. And the procedure for the limiting reactant, if you observe the number of moles, okay, divide by each coefficient in the reactant or in the product if you want to, but this is limiting reactant, this is product, not this is reactant, not product, okay? So we have to multiply with a coefficient, okay, like that. So let's say number of moles, okay, in the standard formula divided by the number of moles as coefficient in the balanced chemical reaction. And then if you can obtain a very small value, then that is your limiting reactant. For example, we have here ammonia and oxygen gas. For example, in the board examination, I remember you need to troubleshoot or to extract blah blah blah, which is the limiting reactant, which is your excess reactant. So you cannot do that by guessing alone. Okay, you should have to have an idea. Okay, something like that. So I remember this. Okay, also it's flashback in my brain cells. Okay, like that. So we have the number of moles through the formula. For example, you are using PBRT. Put that here. And over the number of moles basing in your actual balanced chemical reaction in the reactant. Ammonia, put here. Now, and oxygen also after that. If you can find the smallest number of the ratio, then that is your limiting reactant. From the word itself, limiting reactant meaning minimal. Okay, English, minimal. Okay, excess meaning abundance or over or surplus or let's say too much, plenty, ganon, bulky or whatever. So like that. So normally you use LR, not the excess reactant. Okay, why we should need it? It's already excess. Common sense, okay? Like that. So we need to control on the limiting. Okay, like that. You got the point? Okay? Normally, if you are stable already as a person, okay, you have excess, then we go to the people who have less. We will help them financially. We will try to partner with them with a business or like that, whatever. Let's try to be generous to them because they have less in life. It's gonna be like that on the limiting side, not on the excess, because they are already in abundance. Too much wealth, rich, like that. Okay, why we should go then? We go to the less, less financially capable people. And we will help them to be generous to them. Something like it's just like also a chemical reaction. We need also to focus always to the less. Okay, not the high. Because it will be wasted na talaga siya. Okay, because that's excess, right? Okay, ganon. Ganon siya ang theory. Okay, now, so if I give you so many data, we will use the PBRT equation here because that's applicable. Why? Because there's a volume, temperature, and pressure. Again, if there's a volume, temperature, pressure, use PBRT. That's first technique, like that. Then, if it will not be accomplished successfully, use the combined ideal gas law if there are two quantities to be considered. Okay, so that's why you will say P1V1 over T1N1 is equal to P2V2 over T2N2. But take note, the N there sometimes will be eliminated because we treat 1 mole of an ideal gas. That's why in a combined ideal gas law, we don't put the N in the denominator in the formula already. We have P1 V1 over T1 is equals to P2 V2 over T2, and the N were eliminated. Something like that. You get the point? So sometimes it's gonna be like the first version and the second version have also the end. It depends on how you analyze, okay, on the problem, okay? So it will just be there when you really actual facing the problem. You get the point? This is only a guidance only, okay? The guidance how to solve, not really the exact proper way to solve. Okay? Like that. You get the point? Ganon. So for the ammonia, use PBNRT mga palangga. PBNRT. So we are concentrating with the number of moles. So solve for the number of moles. Okay? Things like this, they are always inculcated. Inculcate in, wow, grabe naman inculcate in your brain cells that always the number of moles will be computed first in this kind of problems that involves limiting reactant, it is reactant, so many data in the reactants of your chemical reaction. Okay, so like this. So N is equal to N of ammonia is equal to the pressure times volume times R times T. Oh, nakakaloka, di ba? Okay, guys, you should remember this one because a lot of problems also in this situation in the board examination. Okay, like that. Okay, so we have the pressure. Okay, the pressure of ammonia is gonna be like 1.45 atmosphere. Okay, like that. In writing also you have to be extra careful, especially to those students that have already eyeglasses like me. Okay, so problem also when we look the numbers, we will, you know what I mean, right? And then sometimes also fast doing the calculation. Okay, so you need to do it, take this one systematically and read clearly something and write also clearly, of course. Avoid erasures, something like that. Okay, it's not really a competition who among you who are very quick how to solve the problem correctly. Okay, the important is the scores you obtain, not the how quick you are, how good you are over the other. It's not like that. Okay, so you have to be extra careful. Okay, the volume of ammonia is 4.85 liters. Okay, like that. Okay, and then the universal gas constant, as I told you, memorize at least two, the liter atmosphere per mole Kelvin, or the 8.3145 joules per mole Kelvin. But the joules, guys, more applicable in the thermodynamics, because heat energy, joules, solo flight siya. But when you speak of liter atmosphere, it let's look a bit confusion. Liter dust atmosphere, it's not practical also in thermodynamics to use that kind of unit, because thermodynamics are always referring to joules, calorie, BTU, like that. Okay, but in this case no problem because this is general chemistry. Okay, like that. Okay, so 0.082. Alam po mag-derive mo in the actual examination. So you should memorize at least a lot of units will be arriving by using PBNRT. Okay? To troubleshoot or to extract the universal gas constant by derivation. Okay? But it will take time for you to do that. Don't tell me you will derive on the actual examination. It will consume your time. Okay? Though you know how to derive. Better memorize at least two, The 0.08206 liter atmosphere per mole Kelvin and the 8.3145 joules mole Kelvin, something like that. And then use remember the compatibility issue of the units. Okay, like that. Compatibility, so that it will agree and it will cancel out and there's no complication of your units. Something like that. Okay, remember that also, Okay, 0.8205 liter atmosphere mole Kelvin, mga kapatid. Okay. Now the temperature is of the ammonia 27 plus 270. Ako na nag-add na guys. Kung ipapas, di ba? 10, 8, 300 Kelvin, mga kapatid. O, ganon. Hello guys! Andito lang ako sa gilid-gilid. I cannot, my whole body cannot be seen during our discussion. Okay? Like that. So, Kelvin cancel. Okay, liters cancel. Okay, atmosphere cancel. What's being left is the mole. So, this is the mole of ammonia. Calculator, please. Ganon, mga kapatid. Ganon lang siya. You have to be patient. Okay? Ganon lang dyan siya. You should be patient. In problem solving, the quality of being patient is very, very important. Just like driving in the road. You should be patient. Okay? The same thing happening in solving the problems. Okay? Everything can be done with patience, because patience is a virtue of most successful people. Really? Okay? Like that. You get the point? Okay, you don't have to rush. Okay? You cannot be successful if you're always thinking to make rush in everything that you do to accomplish certain things. You have to do it in a systematized way or slowly but surely to the final destination. Like that. You get the point? Just like this in problem solving in science or chemistry, physics, like that, whatever. Okay, or math, of course. Okay, 300 times 0.08205 and then 24.615. Okay? Ganon. Actually, guys, I plan to vlog calculus, really, but you know, my brain cells cannot do. Because there's a lot of memorization. From I1, integral calculus, I1 to I27, differential calculus, D1 to D25. So you have to memorize that. Really. Okay? There's no standard in the books like that in examination you have to open and only copy. No, it's not. During the examination, closed books. Okay? So when you say you have to memorize. And you cannot derive one by one also that from I1 to I27. You cannot derive. It's automatic like that. You get the point? Unlike in science and chemistry, you can derive the formula one by one. For example, pressure is equals to force over area. This coming from this blah blah blah, coming from there, coming from there. But for the calculus, no, it's standard already. D1, mo ni siya nga rule. D2, this is the rule. D3, this is the rule. So you have to memorize. That's why that's black to me. I cannot vlog regarding calculus. You get the point? I will resort only to math, algebra, okay, analytic geometry. Geometry can also a little bit easier, and then you know, trigonometry also can be managed. Angles, like that. It can be managed. But calculus, really, calculus and differential equations like that. Too much memorization of the specific rules, like that. Okay. I remember that also. I memorized everything when I was in college. And then we put that in index paper like that, memorized, okay, during riding in a, you know, to commute in a vehicle, okay, while riding, memorize every day, a tool, like that. But it was lost because that was 20 years ago. My gosh. Okay, so 1.45 times 4.85, like that. For me, it's very difficult to memorize numbers compared to memorizing words and statements. Numbers and variables, really, guys, okay? Because statements and words, while you're memorizing it, you can understand word by word, right? So it will reflect in your brain cells. Oh, it's gonna be like this, like that. It's easy rather than figures and numbers with variables. It's very difficult to memorize, and sometimes it will be lost. One thing for sure only I remember is the quadratic equation, the Pythagoras theory, the law of right triangles, the pi 100 over 180, radians to pi 180, how to convert like that. It's only up to there. The quadrants 1, 2, 3, and 4, like that's x-axis, y-axis, the slope, like that. Okay, that's all I can remember. But not the the detailed one. I can't remember now. Okay, my gosh. Okay, that's the basic only kata mga y is equal to mx plus b, mga slope y2 minus 1 is equal to x2 minus x1. Mao gyud na ang akong ma-memorize na mga sa math, sa mga slopes, tuba. Okay, ganon. Ako mga angle of inclination, theta, cosine theta, it's very easy to memorize, right? Because nakasabot ka sa ang opposite side, sa ang base, ganon. Tangent theta, ganon. Because the opposite side over the base. Oh, even though 20 years ago na to siya in my college, I can still remember because I understand really, okay, the requirement of a right triangle, something like that. And then you will draw the Pythagoras theorem, you have the hypotenuse, okay, like that. Even though you don't review, it will just stuck in your brain cells. Okay, that's me. Okay, I don't know with other engineers. Okay, that's only me. I can easily remember. Okay. You get the point? Okay, I can still remember basic formulas and equations, even though that was very long time ago. Exact for the calculus chuba chuchu, or differential equations, mga ganun siya nga. Higher na yun siya ito mga advanced engineering math, mga Laplace equations. I couldn't remember that anymore. Really, guys. Okay? So, ito mga basic, okay na siya. Okay? So, 7.035, 7.0325 divided by 24.615. I-touch lang ko gamay because I love also to vlog math, even though I'm not good in math. Really. Okay? Because if you are an engineer, you are forced to love math. You cannot argue. Okay? Since you are in that profession, you're forced to love math. And then, you learn how to love it. Okay? That's why. My gosh. Okay? So, ganun siya ang mahitabo. Okay, guys, mga palangga. So, 0.2856 ang atong number of moles of ammonia. Ganon. Okay? 0.2856 moles ammonia. Remember, so ito na naisulat diri ari, guys. Ito na siya bilisdan sa oxygen gas. Oxygen gas na po dito. Itong papas-papasa, we need to erase because the dimension, the space is very limited. Okay, oxygen gas, ganon. So, pressure of oxygen gas, take a look there. Okay, 1.6 atmosphere. O, ganon. Volume 5.23 letters. We are just lucky because sometimes these are all a bit of direct substitution. Okay, but sometimes things like this are not really true in the actual board examination. Sometimes you need to think, okay? Not purely substitution. You have to think before you substitute or like blah blah blah. Okay? You get the point. It's not like that all the time. But here, for the purpose of discussion, we need to do the direct substitution, whatever. Okay, something like that. So R, still again, 0.08205 liter atmosphere. Okay? Mole Kelvin, ganon. And then the temperature here, what's the temperature of oxygen gas? It's gonna be, 32 degrees Celsius plus 273. 32 plus 273 is equal to 305. Okay? 305 Kelvin. Okay? Like that. Kelvin always have PV and RT, PV and RT, chuba chuchu. Ideal gas laws, gas stoichiometric problems, always Kelvin. Okay? Unless the question will ask you for Celsius in the end. You have to convert. Something like that. But first, use the Kelvin. Okay? Because it will not agree to your universal gas constant. Use because the denominator is Kelvin. How can you cancel if you use Celsius, Fahrenheit, and Rankine? Okay? Rankine is not familiar, but that is also another unit of temperature. That is 1.8 times, Kelvin. Not Fahrenheit, Kelvin. 1.8 times the value of the Kelvin. That is the Rankine temperature. Okay? Like that. So, we have to cancel the K, letter, atmosphere, mole, ang nabilin ng na. Okay. How can we do this? 0.805, ganun, chupa-chucho, times 305 is equals to 25,025, ganun. Okay. 0.2525, and then 1.6 times 5.23 is equals to 8.368, diba? Okay, and then divided by 25.0252 equals to 0.334 moles of oxygen. Ganon. Now determine the limiting reactant and the excess reactant. Okay, like that. So if there are questions in the future examinations like that, determine the limiting reactant and the excess reactant. So I teach you, it's gonna be number of moles obtained by the PV and RT, any combined gas law or any other gas law formulas, and then over the number of coefficient or the number of moles in the reactant, each reactant. So let's go first with the ammonia. 0.2856 divided by 4 in ammonia here, because 4 is the moles of ammonia and the coefficient. The coefficient is technically the moles we refer. Again, the coefficient of each element and compound in the reactant is what we call as a coefficient. Meaning, the whole number, it's not a point, it's not a fraction, that's whole figure, multiply to a certain element sa kilid, beside, okay, that element and comma, that is coefficient is also equal to the number of moles. Okay, something like that. So, limiting reactant of ammonia, 0.2856 divided by 4, pila siya. 0.2856 divided by 4, naatay kuan. Nakaloka. Ano talaga? 0.2856 divided by, ano siya, 4, naatay 0.0071 for sa ammonia. Okay. Then sa oxygen, I have 0.334. 0.334 divided by chuba chucho. I have 0.111. So the smallest value is the ammonia. So ammonia is your limiting reactant. Okay, because the value after dividing of the ratio is 0.007, whereas the oxygen is 0.1, so it's higher. So oxygen is your excess reactant, okay, and your ammonia is your limiting reactant. Okay, so choose the limiting reactant, which is ammonia, to solve for the volume of N2 produced. Oh, ganon. So erase. So ammonia ang atong ikarga. Get the point? Okay, erase. Okay. We almost there. Okay, mga palangga. Now we have 0.285 moles of ammonia here, right? And now we have also ammonia in the chemical reaction. Now, this 0.2856 moles of ammonia now will be your basis of calculation. Okay? Like that. Things like this. Sometimes also, the basis of calculation will be first. But here, the basis of calculation is the last. Okay? Things like that also. Okay? Because so many given in the data. Okay? Like that. So, 0.2856 moles of ammonia. Okay? Ammonia. So, we are using now the dimensional analysis conversion way of solving the problem. Okay? 0.2856 moles ammonia, then multiplied by moles na nasa ubos ang ammonia, because to cancel that out. Okay. So, two choices could either be in the molecular way, okay, or in the stoichiometric relationship. Okay, like that. Okay, which is which? Okay, like that. So, how can you do that? Okay, going back. Hindi na dipangita, right? So, go to the stoichiometric relationship first, not the molar mass. Okay, unless ang dipangita is also ammonia. But it's not ammonia what is being asked. It's the nitrogen gas. So you have to look directly to the chemical reaction. Okay, moles of ammonia in the chemical reaction is 4 moles. Like that. Okay, and the nitrogen, how many moles of nitrogen in the chemical reaction? So 2 moles of nitrogen gas in the chemical reaction. Okay. Okay. So in short guys, ang stoichiometric number of moles in a chemical reaction is the final round. Just like a competition, a singing competition, or for example, basketball game, or whatever, athletic game. This is the final round to obtain the champion, the first runner-up, the second runner-up. Just like that also in chemistry. This is the final round. Assuming that all the contests are being done, the initial contests are being done, meaning the first step, the second step, the third step, the fourth step. Final round na siya. Mawag na siya for me ang chemical reaction. Okay, now, cancel ang moles, ang habiling, and nitrogen gas. Okay, now, the volume. Calculate the volume. Now, I could not use anymore the STP. Why? Because it's not mentioned here in the STP, there's already temperature and pressure. Okay, I cannot say mole to 22.414 liter. It's very easy to compute for the liters here directly, but in this case, this is not at STP. There's a lot of temperatures and pressures given, so we'll never use that one. That's the first, option. And now we go back again to the PV in RT. Okay, you get the point? So, balik ka po sa PV in RT mga palangga. So, 0.5712 moles of N2. Muna na itong gamiton, guys. PV and RT na po ito. But in this case, the PV and RT of nitrogen na talaga siya. So, the pressure of nitrogen, it's being mentioned there. Okay, produced, it is related and collected at 1.52. Na siya, mga palangga. Okay, then volume, this is asked nitrogen. Okay, the number of moles of nitrogen gas we have computed based on the stoichiometric relationship is 0.5712 moles. Ganon. And then the universal gas constant also 0.08205. Okay, letters atmosphere mole Kelvin. And then the temperature of nitrogen, it's collected at 37 degrees Celsius. 37 plus 273 is equal to 310. Now, solve for the value of V. Okay, basic math. Okay, like that. So, 0.571 times 0.08206 times 310, of course, divided by 1.52 is equals to 9.55 liters. Okay, 9.55 liters of your nitrogen gas. Okay, guys, mga palangga, mag-share na tabo. Okay? Right? Ganon. Okay. This is gonna be the situation. Okay, then if you are not really satisfied with the result, then you need to review. Maybe in the writing only the number, how you substitute it, so like that. But let's analyze if this is true. If I have 9.55 liters of nitrogen gas, so this is now the confirmation if our answer is valid or not. Okay, then if it isn't valid, we need to review. Okay, ganon siya. Okay, so for example, if the number of moles of this is letter, right? For example, if ganun nato guys ha, volume of ammonia, 4.85 liters initially, and then volume of oxygen gas is 5.23 liters. Now, what will happen to the volume of nitrogen in theory? It will increase or decrease? Take note. We have 9.55 here. We increase siya. Is it true that it will increase or not? Guys, okay, so you need to use the equation again, PV and RT. So PV and RT, and then okay, take the relation between the number of moles and the volume. That is the more easy one, huh? Volume and the number of moles, and assume every quantity is to be constant, meaning not changes. Okay, it's just the same. Okay, to prove, so V is directly proportional to pressure, number of moles. Okay? Ako rin guys ha, para ma-prove na kung correct ba ko siya. Okay? So volume nRT over V, P, sorry. Volume is also nRT over P. So therefore, volume is directly proportional to the number of moles. So again, volume is directly proportional to the number of moles. If the volume will increase, the number of moles also will increase, but the pressure will decrease. Okay, why? Because the more you put pressure too much, the volume of the liquid will go down in a container. If it will go down, so the number of moles particles there will be also limited now. So that's why it's inversely proportional with the pressure, something like that. And what happened to your temperature? Okay, again, going back to your in RT. So volume is directly proportional to temperature. So may increase pa ng imong temperature. Ganun lang siya karami guys, ang validity sa atong how valid our answers will be. So if your volume will increase, your number of moles will increase, but your pressure will decrease, your temperature also will decrease. Or increase. Okay? By taking a look with the formula, mo na siya yung mga relationship to prove your answer is correct, ha? Now, if I have, ganun siya yung buhaton. If I have 9.55 liters, okay, sa final round ba ni siya, no? Nasa ko into nga 2 moles. 2 moles. Ganon. So, I have liters of volume. Ilang ito na po? 0.28, right? 0.28 siya. Okay? And then sa volume nato, is, sa ammonia is 4 moles. Okay, ganon. And then sa oxygen gas, ang atong moles is 3. Oh, ganon. Natay 5.23. Ganon. But take note, this 5.23 is the initial, not the final. Okay? So ako itong i-take note atong 0.2856 mole. Atong nakuha ganina. And the 0.3476 moles, right? Now, if we have 0.2856 mole of ammonia initially and a volume of 4.85 liter, what is the volume when it becomes 4 moles? So, ratio and proportion. Okay? Gamay na kaya akong board guys. I can't explain too much. My gosh. Okay, now, volume of oxygen also, if I have an initial volume of 0.23 and the initial moles of 0.3476, and we have also final moles of oxygen in the reaction 3, what is the final volume of oxygen? Something like that. Now, we have the final round of the nitrogen gas. Okay, so that is volume of nitrogen gas initially is unknown, but X. Okay, this is only interpretation so that we can really understand what's going on here. So initial volume of N2 is unknown because we computed the final volume. Okay, like that. So, and then the number of moles, okay, for that is, nakuha na nato diri, di ba? So, mag-PV in RT ta. Nakuha na ba na nato ang in RT? Okay, so N, balik ta, pressure, pila, 1.52, ganon-ganon, chupa-chucho. Okay, ganon. Diba? And then N, R, 0.0613. Makuha na to ang iyang moles, right? Initially, sa nitrogen gas. You get the point? Diba? Makuha na to siya. Kaya na naman tayo volume. Oh, muna naman into. Okay. N2 is equals to the pressure 1.52, ganon-ganon. Okay, times the volume na atong nakuha. Okay, muna siya. And then, R, makuha mo number of moles. Pila man siya nga number of moles, guys. Okay? So, muna siya may tabo. Okay? Ganon. So, makuha niyo ang number of moles. Na kay number of moles N1, nasa kay V2 and N2, right? Ang V2 na to is 9.55, is here. And atong N2, muna siyang sa nitrogen gas na 2 moles sa stoichiometry. Now, we can get the volume initially of nitrogen. Kaya nakuha naman na itong N1, they are is atong PV in RT. So, pila siya. Okay, something like that. Makuha mo ang volume 2. Just to prove kung na-decrease pa siya or na-increase somewhere along the way. Ganon. Okay, guys? Diba? It's very easy to detect na-increase ba siya or na-decrease ba siya. Ganon siya machucho. Okay. You get the point? Ano lang siya? Makuha mo siya, guys. Mag-ratio proportion ka. It cannot be accommodated in my whiteboard. That's why I cannot explain very well. Anyhow, nakuha na nato ang volume. That's what being asked in the problem naman talaga siya, di ba? What I'm trying to say, let's prove if it is valid or not our answer. Something like that. You get the point? Okay. Then, or we can use another thing. Na, kompleto man atong nitrogen and oxygen. So, ato siyang i-ratio dito atong higayuna. For example, if we have 4.85, ganon, and then 4 sa ammonia, ganon. If we have 2, so pila man ang nitrogen, ganon. 2 over nitrogen, okay, and then 4.85, ano din mo, so makuha din mo din na siya. So, 4.85, ganon, chuba-chucho, di ba? Okay, ammonia man itong i-refer. Okay, times 2 is equals to divided by 4 is equals to, nakay kuan. Nakay volume 1 of nitrogen is equals to 2.43 liters. Nara, makuha na. We obtain already the volume initially of nitrogen by using the ratio proportion with the volumes and the number of moles of ammonia and oxygen gas. Okay? Now, nakuha na natin ang initial volume. Now, let's relate that if it is in 9.55, our answer is 9.55. I have to prove if it is correct or not. Okay, 9.55 liters. Now, if the number of moles will increase, the number also of volume will increase. Okay, now, okay, the number of moles of nitrogen gas is 2. You get the point? 2. Oh, let's use this in a PVNRT. PVNRT pressure 1.52. Oh, ganon. Okay, times volume of 4.85. No, 2.43. Right? It's here, initial. 2.43. And then N2 initial times 0.08206 times temperature, mga palangga. 37 plus 273 is equals to 310, mga palangga. So we can obtain number of moles of N2 initially equal to, pilang siya? 310. So, ganun. So, 1.52 times 2.43, mga palangga. 3.6936, guys. And then 0.08206 times 210, mga palangga. 25 something. 4386. So, pila yung kuan. Divided by 3. Okay, ganon. So, ang imong matabunan na yung gayon na, universal gas constant, temperature, ganon, ang pressure yung i-divide. So, 1.52 times 2.43 is equals to 36936. Okay? Divided by 24.4383. Now, we have 0.1511 a number of to initially. Guys, what I'm trying to emphasize first, I need to prove and confirm that my answer is correct. And how can I prove that? Theoretically, by the concept. Because I don't know really exactly if I'm correct. I'm not facing with a multiple choice here. A, B, C, D, E. Though, let us say, I'm confident because I'm doing the right thing in my solution, but I still have to validate my answer. How can I do that? Okay, by doing the relationship between the quantities, what will happen really? Something like that. So, number of moles is 0.151. Now, we have the final number of moles of nitrogen gas, which is 2. Okay, 2 moles. Let's just prove it, right? This is the way it should be, okay? And then what will happen to your volume? Now, you said volume, number of moles will increase, volume also will increase. Now, your nitrogen gas starts with 0.151 moles, and then after the reaction, it yields 2 moles. Now, your initial volume of 2.43 liters and the final should increase because your number of moles also increase. So, my answer, it increases to 9.55 milliliters. So, this is the way how it should be. Because if it is less than 2.43, my calculation is wrong. Because it will not match the theory. You get the point? Okay? Just like a water, you push that with a pressure, something like that. And then the volume will go down, right? And also the number of moles will become lesser because that are referring to the particles. Okay? The atoms in that particular phase, which is a liquid. Mugamay po siya. So directly proportional. If you increase the pressure, okay, and then the number of moles will increase, the volume will increase, but the pressure will decrease. Diba naragin mo guys, ang pressure will decrease siya kung magtaas ang number of moles and volume. So it's true with this analysis, right? From the volume initially of 2.43 liters of nitrogen gas, it will raise to 9.55 milliliter. And from number of moles, 0.151, it will become 2 moles in the final reaction. So normally, the volume of nitrogen gas will also increase. Okay, that's correct. Or else, if it's less than 9.55, 2.43, let's say 1 point something, it become wrong solution. Gi-validate na ako ang akong answer. Okay guys, we validate our answer if it's correct or not. You get the point? Ganun siya. Actually, it's hard already. Because you know, imagine we already get the final volume, and then I still have to think the initial volume of N2 and number of moles. So it do a lot of analysis, right? How to do that. Sakit mo ganyan akong O. Okay? Nakakaloka. Okay guys, ganon. So everything will be in proper order if you follow the sequence how to do it, right? My gosh, I hate drugs. Okay? Any questions so far? Mga kapatid, mga palangga? Any questions so far for the calculations? Okay? Nothing. Right? I think it's nothing. Okay? Hello, shout out mga kapatid, kapamilya, ka-verts, kasosyo, kajowa, and everything. Bye-bye. God bless everybody. Thank you so much for watching. If you will like and comment and share this video, you can do. And you can subscribe to my channel if you want also. And then click notification bell for some news updates of I'm a senior journal voice. Bye-bye. God bless everybody. O, diba? Ganon. Nakakaloka.